In the course of Design Principles of Concrete Structures, Lecture 7, Capacity Analysis and Rebar Guidelines. Rebar mean reinforcement guidelines. Here, capacity analysis of singly reinforced rectangular beam by strength design method mean by ultimate strength design method. Singly reinforced, here you can see in the cross section the reinforcement bars are present at the bottom and no bars are provided at the top. Okay, maybe hanger for ties are present, but the main bars are the longitudinal bars that are present at the bottom. So if in a cross section only main bars are the bottom bars, then this type of section is called singly reinforced beam. In singly reinforced beam, at the top concrete provide the compressive force and at the bottom steel provide the tensile force. If the compressive force is weak, then we enhance its capacity by providing the steel bars at the top of the concrete section also. By doing so, we enhance the compressive capacity of the concrete and in that region by concrete and steel at top of the section of the concrete. So in that type of section is called doubly reinforced beam. Okay, in singly only one type of bars that are acting in the force mechanism. In the doubly, both bars mean bottom and top bars are acting in providing the internal resistance to the beam. Okay, for doubly beam I will discuss in detail in coming lectures. So now for singly reinforced beam, for the analysis of beam, capacity analysis of beam, this data will be given: dimensions mean width, height, effective depth, span of the beam, Fc prime concrete compressive strength, Fy steel yield strength, EC, ES modulus of elasticity of concrete, modulus of elasticity of steel, AS area of steel. Area of steel will also be given. We have to calculate the capacity and how much moment this type of beam can take. Okay, these are the requirements. Means after inputting the data, we have to calculate the moment capacity or the load carrying capacity. So these are the basic steps for the capacity analysis. Okay, first step, calculate the depth of neutral axis assuming this section as under reinforced. When we are going to design any beam, then we don't know either it's a under reinforced beam or over reinforced beam. So before starting the analysis, we assume that the current section is under reinforced. So we assuming that the current section is under reinforced means steel will yield and its strain will be equal or greater than yield strain. Okay, we will use this formula to calculate the Whitney's equivalent stress block diagram. Here Whitney's equivalent depth A, AS Fy 0.85 Fc prime B. Okay, you can also see these all data will be given: Fc prime, Fy, okay, width of the beam, okay, area of steel will also be given. Then we will calculate A. After calculating A, we will calculate C. Okay, we already know A is equal to beta 1 C. Okay, then in the second step we will calculate the strain in steel and check the assumption of step 1. When it means that we have assumed that the section is under reinforced. We will calculate the strain in steel. Okay, now we have C and also D. If our strain in steel is greater or equal to yield strain, then our assumption is correct. Second, then we will simply go for capacity beam moment capacity calculation using under reinforced method. If our strain in steel is less than or equal to yield, then this section is over reinforced. So A is to be calculated again by the formula of over reinforced section. Here A is this formula. A is present on both sides. After simplification you will get the quadratic equation. After the quadratic equation you will get the A. Okay, that is for the over reinforced method. In step 3, decide phi factor. For tension control section, you will select phi 0.9. For compression control section, you will select 0.65. And if your strain value is in between the yield strain and the 0.005, then you will interpolate the value of phi for transition section. Here, final step, calculate capacity, moment capacity, phi Bmn. If that is a tension control, you will calculate A as Fy, because steel will yield D minus A by 2. And if it is a over reinforced section, then you will calculate phi B 0.cc 0.85 Fc prime BA into D minus A by 2. The only difference is in under reinforced, you will calculate A by using this formula. For over reinforced, you will calculate by using this formula. Now this is the second alternative method for capacity analysis for singly reinforced beam. Okay, step 1 to step 3 are for deciding whether this section is over reinforced or under reinforced. Alternatively, it can be done in the following manner. First step is calculate rho, means area of steel divided by BD, reinforcement ratio, and also calculate rho max. If rho reinforcement ratio is less than rho max, then section is under reinforced. The second way, calculate D minimum depth, effective depth. If your provided depth is greater than D minimum, then your section is tension control under reinforced. Selection of steel bars for beams. These are basic and also code guidelines you must have to follow for providing the steel bars in beams. When different diameters are selected, the maximum difference can be of a gap of one size. Means here are the bar sizes, SI bar sizes: 10 millimeter, 13 millimeter, 16 millimeter. Okay, these are the bar designations. If you are providing the bars 13 millimeter, but you have to provide the high reinforcement area, but you do not have 16, you can go for 19, means you can go for one gap of bar size. Similarly, if you are providing 22 and you do not have 25, you can use 29. Only you can skip only one gap. Okay, here. When different diameters are selected, the maximum difference can be a gap of one size. Okay, you got it? Minimum number of bars must be at least 2, one in each direction. Means in beam, you have to provide minimum 2 bars, one in one corner and one in another corner, minimum 2. Third, always place steel bars symmetrically. Means symmetries must be provided in providing the steel reinforcement in beams. Fourth point, preferably steel may be placed in a single layer, but it is allowed to use 2 to 3 layers. Here you can use only one layer, but if you have to provide the more number of bars, you can use 2 and even 3 layers. Okay, and for the gap between, you have to provide 25 millimeter gap between 2 layers. Selected sizes should be easily available in the market. That is very most important part. In your area or your city, you have to visit the market, that what bar sizes available in the market easily. Sometimes some bar sizes are not available easily. For example, 19 millimeter bar or 16 millimeter bar are sometimes are not present in the market. 6 point, small diameter as far as possible bars should be provided, because they are easy to cut and bend and place. Means their cutting and bending are easy for smaller dia bars. And cutting and bending, one more point, and their price given by steel fixtures is also low for smaller diameter bars. ACI code requirements, there must be minimum clearance between bars. Mean this bar and this bar, there must be minimum clearance. Concrete must be able to flow through this reinforcement. concrete must be able to flow through these reinforcement. When we cast concrete, then concrete can easily move around these parts. So minimum gap must be there. Bond strength between concrete and steel must be fully developed if we have provided the proper gap. So what about gap? Minimum spacing must be lesser of the following, means lesser of the following three must be the minimum spacing of these bars. First, nominal diameter of bar. For example, if you are providing number 13 millimeter bar, then one bar diameter is 13 millimeter. So that is the first preference. If you are providing 20 millimeter bar, so 20 millimeter is the nominal diameter of the bar. Second condition is 25 millimeter in beam, 40 millimeter in column. 1.33 times the maximum size of aggregate used. For example, your aggregate size is 20 millimeter. Then the spacing will be 26 millimeter. You will multiply 20 millimeter aggregate size with 1.33. You will get 26 millimeter. Now the minimum of 3 will be the spacing. Okay, so you can also provide, we can also give an additional margin of 5 millimeter. For example, if you are have selected out of 25 millimeter, then you can provide additional margin of 5 millimeter, say 30 millimeter. Here these are three requirements, but still a minimum clear gap of 25 millimeter is to be provided between different layers of steel. Even different two layers 25 millimeter should be provided. The spacing between bars must not exceed a maximum value for crack width control, usually applicable for slabs. When we go for slabs, then we will discuss that what are the maximum spacing of bars in provided in the concrete. What is detailing? Detailing is after designing the beam, we have to sketch that section into the drawing so that we can give this drawing to the contractor. So after getting the drawings, contractor can cast the concrete and cast the members as per specification. That is called detailing. In the detailing, we have to decide diameters of bars, what diameter should be provided, decide number of bars, how many bars will come, decide location of bent up and curtailment of parts, making sketching of reinforcement. This is called detailing. Concrete cover to reinforcement, that is also very important. When we provide the reinforcement, we also provide the concrete cover. Okay, why we provide? To prevent corrosion of steel. If we provide the cover, then it will definitely protect the steel from corrosion. To improve the bond strength, definitely. Okay, if the concrete is present around the bars, then definitely it develops the strong bond between the steel and concrete. To improve the fire rating of building, if you provide higher thickness of cover, then definitely your fire rating is good. But for normal, for 2 hour or 3 hour fire rating, okay, as the minimum cover that will cover the 2 to 3 hour fire rating to the building. Okay, so that will also improve by providing the cover of concrete. It reduces the wear of steel and attack of chemicals, especially in factory area. Okay, if the cover is not present, then definitely the chemical present in the factories contaminate or attack the steel bars, and our steel bar go under rusting, and the main force carrying element of steel weak its strength, and ultimately the failure of the member will occur. So that are very important. Concrete cover to reinforcement. Here are the minimum clear cover requirements as per ACI code. Okay, concrete permanently exposed to earth. For example, for foundations, you have to provide 75 millimeter cover. Concrete occasionally exposed to earth or weather where rainy, etc. For number 19 to number 57, 50 millimeter. For number 16 and smaller bars, 40 millimeter. For sheltered concrete, the concrete normally in the plazas, residential buildings, for slabs and walls, that should be 20 millimeter, for beams and columns 40 millimeter. These all minimum cover you should keep in your mind because these are very important. Number of bars in a single layer. How many number of bars we can provide in a single layer? Okay, that we can also just by our observation, our experience, we got this observation. We do not need this formula for every time. What this formula I will show means number of bars in a single layer. How many number of bars we can provide in a single layer? Okay, this formula should be rounded to lower whole number. Okay, BW in this formula is the width of the web of beam. For example, beam with width 300 millimeter, if the width of the beam, okay, beam, here is the width of web of beam. Here is the rectangular section, this bottom end, that is the web of the beam. If there is a T section, then the web width of the web of beam, that will be bottom part. For example, beam with width of 300 millimeter, number of bars in a single layer will be equal to 0.02 into 300 minus 1.4. The answer is 4.6. We have to round it to lower number 4. It means in the single layer we can provide number of bars 4. So that's how formula is used. Next, this is an example. A singly reinforced rectangular beam has a width of 228 millimeter, an effective depth of 450 millimeter. FC prime 17.25 megapascal and Fy 420 megapascal. Calculate flexural capacity for the following three cases. Mean for the following three cases we have to calculate the flexural capacity, mean movement capacity. First, 2 number 25 bars, SI size, 3 number 25 plus 2 number 15 bars, and capacity for balance steel. Okay, three conditions. So that's all for today lecture. In the next lecture I will solve these examples, solve this example with three sections. So have a nice day.